So this video is going to be about quadratic equations in standard and vertex form and finding kind of the features of quadratics. So vertex form is what we saw in the transformation section. It's the ax minus h squared plus k, and that's where hk is the vertex. Remember that h shows backwards as the actual sign on the vertex. That's that left-right shift. So the first question is asking, find the coordinates of the vertex from the equation. Does the parabola open up or down? So let's do up or down first. Get a pen out. There we go. Scoot that over here. So it's got a negative in front, so that's our reflection across x. So that's going to open down. And then hk is our vertex. So hk would equal, remember this is going to be a negative 1, because when we put the negative 1 in for that h, minus negative would show as a plus. And, so I should have parentheses there, and 20. So our vertex is at negative 120. This next question is asking us to find the equation based on the graphs. I think we probably did this in the last section, but it's just kind of a reminder of vertex form and how that works with a graph. So this is going to be y equals, if we look at that graph, actually let me get rid of that and write out the vertex. The vertex on this one is going to be positive 3, negative 2, and if we look on our graph, it's going over 1, up 1, so there's no negative in front because it's opening up, and there's no stretch because it's only changing by 1 unit like our parent function. So this would be y equals an invisible 1 out here, x minus 3, so there's our right 3, and then minus 2 on the outside, our down 2. So for this one, our vertex is at negative 2, positive 2, and our shift, or our stretch, there's our vertex, and it looks like our next good point is 2 units down, so our stretch in front is going to be a negative 2 because it's opening down and stretched by 2. So I probably could have picked an example with fewer 2's in it, but here we are. So negative 2, and then x minus that negative 2 would be plus 2, and shifted up 2 units on the end. So 2. This one, a quadratic function has its vertex at the point 2, negative 3, and passes through the point 4, negative 11. Find an equation for the quadratic. Okay, so what they've given us, let me write out our vertex form. Y equals a x minus h squared plus k. So to find the equation of a quadratic in vertex form, I need 3 things. I need the vertex and I need the stretch. I have the vertex, it's right there. There's my h and k. They gave me a point xy that's going to have to satisfy this equation. So if you look, that's 1, 2, 3, 4 of the 5 variables. So if I plug all those in, I'm able to figure out what a is. So, and this isn't saying that, x is always 4 and y is always negative 11. It's just that this point satisfies the equation I'm trying to build. So we can use it for x and y. So y is negative 11. A is what we're trying to work out. X is 4. H is 2, so 4 minus 2 squared, plus k is actually a negative, so minus 3. And now I can solve this and get a. So negative 11 equals 4 minus 2 would be 2 squared would be 4a minus 3. Add that 3 over to the other side and get negative 8 equals 4a, divide both sides by 4, and negative 2 equals a. So what does that make our answer? That would be y equals a is negative 2, x minus h was 2, and k was minus 3. Next one's the same thing, but just with a y-intercept. So y equals a x minus h squared plus k. Vertex, there's our hk and our x and our y. So y is negative 2 A is what we're looking for. X is 0 minus a negative 4 right there, squared plus 1. So negative 2, 0 minus negative 4 would be 4 squared plus 1. We can go ahead and subtract that 1 over there and get minus 3 equals 16a. And then divide the 16 and negative 3/16 equals a. So y equals negative 3/16 x minus a minus would make that a plus 4 squared and plus 1. So the next thing we have is how we can find the vertex of a parabola without it being in that form. And there's two ways. So there's two forms that we see parabolas in: standard form, which is what this one was in, and then vertex form, which is what we're just looking for. This one is asking us to go from standard form to vertex form. So we have a couple of ways we can do that. We have this formula that's going to let us find the vertex. To find the x-coordinate of the vertex, we can substitute in b and a like we did in the quadratic formula. So x equals negative b over 2a. Solve that out and we'll get the x-coordinate. We can plug that back in. That's what this is saying. So plug that value, once we know x, plug it in and get the corresponding y. And then when we have the vertex, then we can fill in our hk there. And then the a, if this had a 2 out front or a negative 5 out front, that's where we would find our a. So let's look at it that way. So x equals negative b, so negative 6 would be 6 over 2a, 2 times 1. So 6 divided by 2 makes 3. So that means my h is 3. It's the x-coordinate of the vertex. To find y, we're going to plug 3 back in and then see what y comes out. So 3 squared minus 6 times 3 plus 5. So y equals 9 minus 18 plus 5. And 9 minus 18, so that'd be negative 9 plus 5, negative 4. With that, we can then write down, slide this up. Since we know our vertex, we can write our equation now is y equals x, because a is 1, so x minus 3, minus 4. So that is one way to do that. Here's the one that you won't like, but it also exists. And this is a place where we can use completing the square. And kind of the same thing I said last time is if this is 1 and this is even, this isn't a bad way to go. If this wasn't even, then there'd be fractions, and I would probably go with it, doing it this way. So the way that we do this for completing the square, remember in the previous section we did half of 6 is 3, 3 squared made 9. So we add 9 right there, but instead of adding 9 to this side, we just subtract 9 at the same time. Which seems weird, but it's the same thing as if I added a 9 over here and subtracted it on the next step. So I'm just going plus 9 minus 9. So it's the exact same equation as I started with. These would just cancel. But what it does is it gives me this piece, which now factors to a perfect trinomial square. Multiplies 9, adds to be negative 6, so negative 3, negative 3. Negative 9 plus 5 is minus 4. So I'm pretty good at this, and this is easier for me because I'm pretty comfortable completing the square. You may not be as comfortable completing the square and going through and plugging in, using negative b over 2a to get the value and then plugging that in to get the corresponding y. That may be a better way for you. This is going to show up again in the next course, so you will see it again, but you can't escape it this quarter by just using vertex. This one's the same thing, so if I completed the square just to do it, y equals x squared plus 20x. So I'd say half of 20 is 10, and 10 squared makes 100. So that would be plus 100 minus 100 plus 99. And then that piece, that's my perfect trinomial square. That negative 100 is just to balance out this 100. So it just gets rolled in with the k term. Because this would be 100 and adds to 20, 10, and 10, which is what we just made it do. And negative 100 plus 99, that would be, I keep doing that, minus 1. And that would be in vertex form. So again, if you can do this, it's pretty easy math, once you know how. So if we do vertex form, this is going to go negative 20 over 2 times 1. Negative 20 divided by 2 is negative 10, so there's that same 10 that I got right there. And then the y on that is going to equal this evaluated negative 10, which is the part that I find annoying, and that's why I prefer to just complete the square when I can. Plus 99. So that is 100 minus 200 plus 99, which is 199 minus 200, and then there's the exact same negative 1 that I got from completing the square. So again, either of these two methods work. Whichever one you prefer is a good one for you to do. For these last few, they're asking us a few more questions. They're asking, does it open up or down, find the vertex, find the axis of symmetry, and find the x and y intercepts. So let me go back to this box for a second. We already looked at if it opens up or down. If it leads with a negative, it opens down. If it leads with a positive, it opens up. To find an x-intercept, we let y equal 0, same as every other x-intercept ever. So we just would let the y-coordinate equal 0, and then factor or use the quadratic formula as we needed for solving it. To find the y-intercept, we just let x equal 0. So if we're in standard form, the y-intercept is super easy because it's the number on the n, because those x's drop out. Notice it's not the k, right? If we put a 0 in here, that's not, and it's h squared plus k. But if we're in standard form, it'll be the number on the end. And then the axis of symmetry just equals the x-coordinate of the vertex. And what that is graphically is, if I have some graph of a parabola here, it's the line that if I folded the parabola over, it would sit on top of itself. So say right there I was at 3. That would mean x equals 3 would be my axis of symmetry. And careful when you're typing these into answer boxes. The axis of symmetry is not 3, it's x equals 3. It's that vertical line through 3. So you need the x equals part. Okay, so let me show you that with some examples. So determine if it opens up or down. So this one opens down because it has a negative. Find the vertex. If this is a negative, I would probably just do vertex form. You could complete the square, but you have to do a little bit of fancy factoring, and most folks are not going to prefer that. So negative b is negative 8 over 2a is negative 1, and so that is positive 4 with the double negative. And then we'll plug the 4 back in to get the y, so negative 4 squared. Notice that's not in parentheses, so it's going to be a negative 16 because it's the negative of 4 squared, plus 8 times 4 minus 7. So y equals negative 16 plus 32 minus 7, and y equals 9. So our vertex is at 4, oops, that's not a very good 9. So we got the vertex, we got the up, we got a down. Axis of symmetry, so now that I know the vertex, the axis of symmetry is just the x-coordinate of the vertex, so that would be x equals 4. And think about if this was over 4 and up 9, we'd have a parabola shifted over 4 units, so a vertical line through 4 would be like if I folded the parabola over on top of itself. That would be its axis. X-intercepts, so let's say negative x squared plus 8x minus 7 equals 0. I would try multiplying that all by -1, just because if it does factor, it's much harder to see with a negative squared term. So let's do a -1 on both sides. Make the signs a little easier. So x squared minus 8x plus 7 equals 0. And then are there two numbers that multiply to be positive 7 and add to be -8? There are. So that means we can just factor it. So it sounds like a -1 and a -7 would multiply to be positive 7, add to be -8. So x equals 1 or x equals 7. So that would be our x-intercepts. And then our y-intercept is right there at -7. And again, the reason for that is if we put in 0, oops, keep doing that. If we put in 0, the two terms with the x drop out and we're left with y equals -7. In terms of the answer entry, just kind of careful for what it's looking for. It depends who programmed the question, but sometimes it might want 1 0 7 0 as ordered pair, or it may say list your answers, give your answers as a list. So then it would have an answer box and we just do 1, 7. And same thing here, it could ask for as an ordered pair, or it could just have an answer box where it has the 0 in front and you're only having to enter the -7. But just be a little aware of how they want that formatted. This last one is basically the same thing, except for there is one difference there. So we're still finding up or down vertex axis symmetry and x and y intercepts. So if I do, it's going to open up because it has a positive x squared term. If I do the vertex, let's see, that's going to go x equals -4 is 4 over 2 times 1, which is 2. Plug in a 2 there. And y equals 2 squared minus 4 times 2 minus 10. So that is 4 minus 8 minus 10. So 4 minus 8 would be -4, and then I feel like I have a sign there. Just checking my signs. Nope, I have it wrong in the notes. Okay, cool. So this would be, this is a positive, so that's 2 squared, and then -8 minus 10. So 4 minus 8 would be -4 minus 10 would be -14. And so we got our vertex, and then when we go to find our x-intercepts, right, so we'd have x squared minus 4x minus 10 equals 0. And when I go to solve that, there is no number that multiplies to be -10 and adds to be -4. So that's where factoring failed, and so I can either complete the square or use the quadratic formula. With this one, I think it's to 2 decimal places, so I might as well use the quadratic formula. If we do that, we're going to have x equals -4 is 4 plus or minus -4 squared minus 4 times a times c. All of that is over 2 times 1. So cleaning that up a little bit, I'm going to have 4 plus or minus, this is going to be 16 plus 40, so that is 56 under there, over 2. And then like we did in the earlier section, we'll do 4 plus root 56, hit enter, and then divide by 2. And you should get the positive one was, where to go, 5.74 is what I got. And if you do 4 minus square root 56, enter, and then divide by 2, enter, you get -1.74. If you want to type that all in at once, you just have to be careful to put parentheses around that before you hit the division. Otherwise, that 4 isn't being divided. So those will be your x-intercepts, and y-intercept is right there on the 10, so the y-intercept is going to be -10. And, I think I forgot the axis of symmetry. That would have been x equals 2 over there. And I think that wraps up vertex and standard form.